Okay. So in this lecture here, we're gonna continue to cover some aspects for the EM waves. After we cover the range, now we used to go back for the last week lecture when we mentioned about the Maxwell law, which basic in observations, the ratio of electrical field divided by the magnetic field all the time is constant, which equal speed light. So we solve some problem here to use that relation to identify or to find the electrical or magnetic field based in the problem. Let's start with the first one. So the first one, we given the what ask you to what to find the or what is the magnetic field for the electromagnetic radio wave. It has certain frequency and it has certain electrical field, and we asking to find the magnetic field. So here is the frequency is out of the contact, so we mean we don't use it in this problem here, just as the extra information. So basically what we're looking for this the formula that we're gonna use, and we are given the magnetic field, electrical field. So from this problem here, we can find the magnetic field, which basic in the formula E0 divided by C. I have my informations. I have here is the 15 volt per meter divided by constant value power to the 8 meter per second. Be careful with the units, guys. Here we are given 5.0 power to the minus 8 as a unit volt, and second will go up, second divided by meter square, which basically Tesla. A small magnetic field comparing with the electrical field. Let's move for the second problem here. We are given typical magnetic field for the radio for about this was the microwave radio, and it has the magnetic field 1.4 power to the minus 10 Tesla, and you ask to find what the electrical field. Again, we're gonna use the same formula, but in this case, we are asking to find electrical field using that formula. I have my constant 3.0 power to the 8 meter per second. Time is my magnetic field power to the minus 10 Tesla. And if you multiply this number here, you end up with the 4.2 power to the minus 2 volt per meter as a magnetic field. So this is the how to use this formula to or this ratio for the electrical magnetic field to calculate one of the others. So let's move for the second topic here, how to calculate the intensity of the EM waves. And the starting point, starting from the power, which the general concept for the power, as a definition, it's energy per time, or the ratio per energy time, as the unit energy joule divided by time second, and this is ratio we call it, or that's what we call it, watt. Over here is we call it watt. Okay. Similarly, now for the intensity of the EM waves, identify as a power per radius, or a power area ratio. As the unit, it will be watt and the m square. M square. So let's take this example here to find out how we can use this formula in our problem. Here is we have a 200 megawatt laser pulse, using the laser pulse here, and focusing in lens in the wall with the diameter 2 micro, very narrow area, the wall. The first you asking to find the intensity. Second one, they ask you to find the E, or the electric field. So we're gonna use the first formula to find the intensity. Then I'm gonna use the formula for the E, half of the C divided by epsilon O divided or multiplied by square of electrical field. And this is the formula how to calculate the intensity of the EM wave. So the first one, intensity based on the first formula, power divided by area. So the area that we have circular here, that's our area. So I have 200 power to the 6 watt divided by R. This is my area. R square we have here is the radius, diameter. So power to the minus 6 meters. And don't forget the square here. And this number here will be very big number, 6.4 power to the 19. Intensity will be watt per meter square. Now we're gonna use the formula for the I equal this part. So I have 6.4 power to the 19 watt per meters. And this one is equal a half multiplied by constant C, 3 power to the 8 meter per second times epsilon. It is power to the minus 12 column square in Newton times meter square. And this one times square of the EO square. So we're gonna divide by the entire this number here, and then we take the root square of this value. So we end up with the E from this formula here will be 2.2 power to 11 volt per meter, which is very large electrical field here. That's why we mentioned that laser, it's very dangerous to use. Here's more example. Here another example regarding for the microwave, and we have the microwave. It has intensity 5 kilowatt per meter square, and asking for the strength of the electrical field, which basically the same previous example here, starting from we have the value of 5.0 power to the 3. Here is the watt per meter square, and equal half. I have a constant 3 power to the 8 meter per square meter per second, and multiply by the epsilon 0, which 8.85 power to the minus 12 column square in Newton times meter square times E0. Similarly, we can find from here, we can calculate our E after we take the root square. I hope you can find this calculation and you confirm it. 1940 volt per meter. So this electrical field, if you compare this value with the previous example regarding for the laser, you see the comparison when you're talking about the laser has very strong electrical field. The last problem here, we are given here for the cell phone, and it has intensity of the electromagnetic wave. It is 40 meter per second. 40 watt per meter square. The ask you to find what the electrical and magnetic field amplitude of this wave. So generally speaking, regarding for the way for the phone, the safe range for the intensity that you can human being will be safe to apply this one. It is 10 milliwatt for centimeter square. If you change it to the what we are meter per second square, and this one is equivalent to the 100. Let's do it in that way. 100 watt per meter square. This is the safe range. Now, regarding what we have here, we have intensity, and we can use the same concept that we did last time. So what we have the intensity here. So and it's the same formula that we use, or the same here the intensity equal a half C epsilon 0 E squared. We have all the information that we need, so we're gonna calculate as the previous two examples. I hope you can calculate it. You end up with the E equal 170 volt divided by meters. So from here, we can go back for our starting point, which C equal E over magnetic field. And we can find our magnetic field. It will be based in the light of speed times electrical field that we found in the previous one. And this one, by the calculations, you end up with the 5.8 power to the -7 Tesla, which is very small comparing with the electrical field. Okay, that's some example how to apply or how to find the intensity and how to find the electrical or the magnetic field in that case.